Okay, so in this lecture, we are going to continue our discussion about Chapter 19, Java Collection Framework. This example about the set interface. Okay, so we are going to continue use that book class, and we are going to use the set. So all of the set interface, okay, sub-interface, a sorted set, a navigable set, and a tree set and hash set. Both of them are the classes to call the class. Okay, so let's take a look. And keep that in mind, set only allows unique item be stored. Okay, so we first create a hash set. Okay, so it uses set interface for static type, and dynamic class is a hash set. So we add 4 books, and for the second set, it's a tree set. Okay, so this tree set sorted by name. So different. Okay, so here we just directly, so this is at a comparator interface. Okay, because it's a functional interface, so here we use a lambda expression directly. Okay. And we add 3 books. Okay, and then we add the second set to the first set. And so all of these operations are pretty similar as the previous ones. Just create our data structure and add new items to the data structure, okay? And then output the data structure. And here we create a new book and we add it to the set. So the ID the same, but the name is different, so it will be allowed. And then we check the search. Okay, so similarly as and we do the iterator. And, so that's regarding the general set, the first part, okay, and you can check the output and the iteration, okay. And then what we do is we create a sorted set object, okay, and we use a tree set, and this time also sorting by name, okay, and so we just import all of the items from the set. And then we can take a look at the first and the last item in the sorted set to see if it is sorted, and also we can output the complete sorted set. Okay, so let's take a look. Yeah, if you take a look, you will find, yeah, it's arranged this time. First is all A and the last all C, is it? So if we take a look, yeah, because it's sorting by name. So it does work. Yeah, yeah, it does follow. And here is the sorted order. Okay, yeah, so that works. And then let's see. What next we do is these are the methods that to get some subset. Okay, so this is the first subset of the book. It's called have set based on that B0. And we can see the output. So B0, I believe it is this is the B0 book. Okay. So the headset will get basically the left part of this sorted set. Okay. So that's a head set. And tail set will get, if you take a look at the second, so it will retrieve all of the items, including itself, to the right part. Yeah. And you can also call subset to specify with the two items. So it looks like it's try to get the items in this range. So you can specify, okay, the starting and the ending, okay. So this is regarding sorted set, and because it's sorted, so we can go ahead to take advantage of that to find a certain subset with the head and the tail. And what the next one we did is we create a navigable set. Okay, still we use a tree set to create the objects. Okay, and then we just try to do like the ceiling book, so book all of the book up to this book. Okay, and also the floor book up to that. And we can take a look what the output is. You can take a look, okay, the ceiling is book up to, is it? It will try to find the one that's closest to this one, okay? Yeah, closest to this one, then the other one is also, so this is the closest one, closest one from right. Okay, the other is closest to one from left. Okay, so we have, and then we also output the complete set. We can take this is a complete navigable set. Is it? So the item we try to find, this one doesn't exist in the set, is it? But because we sort with the name, so it's all capitalized, is it? The capitalize start as 221 with a C, okay? And this is a reverse order, okay? So, so this should the original order. So it comes here, is it? So that's a left and that's a right, is it? So this one is all capital, so that's why this one is the closest from the left, and this one is from the right close, even though this item doesn't exist in the set. Okay, so you can still look for it. And then we can also find like higher or lower. Yeah, so it's this item does exist in this item. Okay, so then the book higher up to 131. Oh, that's previous, this output, okay. And then this two output is from this one. So similar, okay. So higher and lower, similar as the ceiling and the floor. And also we can reverse the order of the navigable set. Okay, so you can call it descending set. And then you can see the output is in reverse order. And then next, let's see what we have. And then we also try to find what's the first, what's the last item, and after we remove an item, does it change? Okay, and we can also see because we fill the navigable set with the original to see after we will the original be impacted. Let's take a look in output. This be this one. So after this one, we get the first and the last book. Yeah, so the first one and the last one, we did get it. Okay. And then we remove the front item. Okay. And we now try to see what the what the navigable one it is. Okay, so you can see this one is removed because we call this is it, and we also call this is removed. And what else? We also remove something B0. So we remove three items, okay? So if you take a look, it start at B, okay? And ending at this item, okay? And 221 still there, B0, so AAA, and so looks like this item is also removed. So we remove the three item, okay? And then let's see the original not impacted. So that's good, okay, because here we didn't do any shallow copy. Okay, that's good. And then next, what did we do? For the next section, what we did is just as usual, we converted to array and then call the string filtering for each using the concise way to complete a couple of tasks just in one single statement. Yeah, that's just the same as what we did previously. Okay, so that's the discussion about this example. So we will come back in a little while for the next example. See you.